including, you do 35 to 60, and if it is including, you do 36 to 60.
Let me work it through here in a second. I'll show you here. I'm gonna say that if I have a boundary one, I'll say I'm gonna include them.
I just don't want to get confused on this quiz model.
I don't. That's why I'm gonna finish the way that I'm saying that they're included first. Okay. So if I'm gonna include them, that means, remember, the CDF function will take you up to this value between 0 and 60. That's what I want. And then I want to include 36. But if I did the CDF of 36, I'd subtract the 36, and that's not what I want. So I'd have to start it at 35. Okay? So I'll have a 60, and then I have to subtract out of it ending at 35 then, with the rest of the same value.
I gotta fix that.
And that'll give me my boundary including 36 to 60. Does that make sense? Now, if it wasn't including this, if I just wanted to say between 36 and 60, unincluding, that means my upper boundary.
You said unincluding, and I was trying to think of what that would be. You put two prefixes over there.
Sweet. I'm making up words. So if we're unincluding, excluding, if you will, I would start it at 59. And then, yes, 59 and 37, because that 37 is between 36 and 60. See how that works? That's why the number line is helpful, to think of where you're looking. Yes, ma'am.
So even though like we're writing k is like greater than or equal to, the equation doesn't count that equal to, it's just counting the greater than part?
It's the CDF function accumulates it from 0 to whatever your k value is. So your CDF functions are great for less than or equal to. When you do the greater than or equal to, you go one fewer and complement it. Because you want to go the other way. That's the difference there. I've had quite a bit of questions today as far as variance between the Bino PDF.
I whispered it. How
I
did
know
you hear that?
I'm a teacher.
I whispered it.
And a father.
Did you know?
And a father.
Teacher says
I said and a father.
And a bum. I'd like call you a bum.
How would being a bum assist your hearing?
What?
How would being a bum assist your hearing?
Take out all your fun.
All right, now you are a bum. No.
Binomial PDF. We used binomial PDF was great for finding singular value or using for lists. We could have done it once. We found out, we used that binomial PDF function. Remember back when we did the experiment of testing about UFOs?
Oh, yes.
Where we did, it was, we had 0 through 11 trials. This was the one in the book. And it was the p-value of 0.37. And you guys had to go in and you entered in your L2, all that. We found out after, well, I figured out after class that if I did a binomial PDF of just 11,0.37. Let me clear this out here real quick. If I wanted to create a list of 0 through 11 and then a binomial distribution of all of those values, all I do is this. I would go through stat, edit, L1, I'll put 0 through 11. Oh crap, did I put 11 or 2? There we go. Okay. Then for L2, remember we had to go through and type in all those combination problems with you did all that long form?
Oh, yeah.
The PDF version will do it quicker. Here's how it works. if you hit second bars up, your final PDF is option A, okay? What you're gonna see here is gonna be a little bit different from what you guys get. You guys just automatically get a parenthesis. All you have to type in is 11, comma, 0.37, close the parenthesis.
Where'd you take me at 12?
It's a quick.
Where'd you take me at 12, Charles? It's 0 to 11.
It starts at 0 though, but it knows that it starts at 0 because it's gonna pick it at when it chooses 0, a 0 occurrence through 11. It includes the 0. It automatically does that. So your calculator should look like that. If you hit enter, it's going to come up with this whole list. If you don't press any buttons right now and just hit the right arrow, you can scroll through all the different values that are in there, which is fine.
How? It just doesn't move.
So it just means you hit the arrow, you hit enter too many times. It's no big deal. Because now what you can do is take this answer, second answer, and I'm going to stow it in L2. Okay? If I stow it in L2, if I go back to my stat now, I can actually just see all of it in the list. It's just a faster, the PDF version is a faster way to import multiple binomial occurrences. That's all it is. The advantage to that was there was a problem on one of the worksheets when it was talking about expectant male puppies.
2.5.
Right, it was at 0.5 out of 11. This, if you had it and you were going through your alpha, instead of calculating all 12 of those possibilities, if you sent the list to L2, you can scroll down and see which one of those percentages gives you the greatest value. The biggest possibility of occurring the most males. That's really the only time that PDF function worked for us nicely. We normally use the CDF function. Miss Jenna.
How do you know the difference between when to use them? Like the CDF versus PDF? Well, I'm really confused. Like, it just make it concise.
I'm doing that right now, Jenna.
Well, if you have a CDF, you have all 3 values.
If you have the CDF, you can have all 3 values with PDF as well, because you can ask for a single value. It'll just give you that answer at 3 trials, versus the CDF value is cumulative. It's going to add it from 0 to 3. You use the CDF value when you have your K is less than or equal to 3. Or your K, because this is going to add up when K is 0, 1, 2, and 3 and give you some answer.
So you use the CDF when it's like the greater than, is like a
Greater than or you're less than, or greater than or equal to, less than or equal to symbols. This one is when you're using lists or a single value.
Thank you.
Okay. That's how that works. I think we might have used CDF a whole lot more than we did at a single value. Because if it's single value, it takes too long to figure out all this stuff when you can just do a 11, choose 2 of your expected 0.37, squared, and then 0.63 to the 9th power. And you do that just as fast when you use your binomial. Because that's what the PDF does. Okay? Your PDF function does that for a single value. The CDF does it for 0, 1, 2, 3, up to whatever your K value you're looking for. All right?
So it does like the whole binomial thing up to a certain.
Yes.
And
That's why it's cumulative. So what it's doing is it's going to add up all these values in the list, so you don't have
It'll
to.
do like 11 choose 3, then 11
Yeah,
choose
it does it automatically. Calculators are cool.
But how does that apply to the bell curve we were doing the other day?
The bell curve stuff, the way that it works with the bell curve is that when you have an end value that's large, binomial distribution tends to lead itself to look normal. It may not have all the attributes of normal, but it's close enough. So you can use some of these shortcuts to give you rough percentages. So when n is abnormally large, a couple hundred here and there, you can assume that it's going to be distributed normally. And that does occur. You don't have to get into full logistics of it and how it breaks itself down. But if you have an end value that is large and it doesn't say that it's normally curved, you can assume it is binomially because you can use those same values.
Okay.
So Bino CDF allows you to do normal curve stuff without it being normal. Does that make sense? It's just a nice little shortcut that I'll let you guys use because it's close enough. It really is. I mean, the stuff that we're doing right now are things that you're not going to see on an ACT. You guys probably, most of you guys probably won't take stats in high school. You probably won't see any of this stuff again until you get to a college stat class, and it's going to be a lot different. Okay? We're just talking, there's very small things that we're looking at. We're just scratching the surface. The whole idea of norming data to make it look to those percentages just is all stats does. Yeah, listen. I should say hi. Hi.
Hi.
How are you?
Good, how are you?
I'm great. Is this for me?
I don't know.
Oh no, it's for him.
Yeah.
Good to see you.
Thank you too.
Wait, guys, it's about the same, doesn't know who that is.
I do. It's Amy.
That's not.
You seem grumpy today. Are you okay?
Cracking your cornflakes.
Anything else on 12.7?
Never.
I'm looking at stuff. So when I was going through the stuff early last night, trying to figure out what did I actually want to spend some time on and talking about, I wanted to re-emphasize a couple of things from counting cards, as well as looking at some of the problems in this review stuff here. The test itself is just 12.1 through 12.7. You took a quiz already on the 12.1 through 12.4 stuff, and more often than not, the things that you kind of made a goof here or there on was the idea of the card stuff still. So if you happen to still have it on you, great. I'm just going to kind of walk you through a couple of again, just to remind you. So you want to have 3 spades and 2 hearts. In a 52 card deck, 3 spades, 2 cards, what you're looking at is not a probability of getting that. You're looking at how many possible how many occurrences are there in 5 card draw. Yes, ma'am. If I ask you to find the probability, you remember how to find the probability, or do you remember how to find the total of all possible hands in a deck of cards? How many cards are in a deck of cards? 52. And how many cards are we dealing out? 5. So it would be
52 choose 5.
52 choose 5. That's your total possible. It's like 2.6 million-ish. A lot. Okay. So when you're looking at something like this, you've got spades, then hearts. You're just picking suits. Okay. So what do you have to pick first? Suits.
Oh, yeah.
Suits. So you have how many suits? How many do you want to choose? So you have 4 to choose. One of that suit, how many cards are there? There's 13 cards. How many of those 13 do you want? 3. Now, how many suits are there?
3.
How many of those do you want? How many cards are in that suit?
13.
And you want 2. What this is telling you is that you're just looking at getting 3 spades. It doesn't matter which card it is, it just has to be a spade. You want 3 of them. Okay? How many possible hands are there in a 52 card deal? Out of the 2.6 million that are possible, how many of those will have 3 spades and 2 hearts? That's how many there are. The difference between that and getting more specific, where you're looking at, what was the one I had on here? 3 of one kind or 2 of another. When you're dealing of one kind, 2 of a kind is a pair. 3 of a kind is like,
A crowd.
it's a pair plus 1. Crackle?
A crowd. Crackle. Don't throw it at me. Don't throw money at me. It sounded really bad.
So if you want to get, if you start thinking about, you're looking to get what's called in poker a full house. Full house is 3 of a kind, 2 of a kind. Okay?
I get that in Yahtzee.
That's all it is. It's Yahtzee. You guys have played Yahtzee, right? Same idea.
My grandma plays Yahtzee. My grandmother's playing every single
My
day.
kid plays Yahtzee.
My grandmother's playing every single day, and I play with him sometimes.
Wait, what's the odds?
Don't make fun of my grandma and grandpa. I love them. My grandpa and all her dad.
Not as a child, like, like, I used to play hockey, and I feel like finished. That's always heart attack. Really good at making tears come so good.
I'm a math teacher. My wife's a science teacher. But it's gonna be one of those things like, I don't have any homework. Yeah, right.
Nice try.
No, break the system so that that you're done for 2 to do that way you know you get done.
So you want 3 of a kind, 2 of a kind. The first thing you have to do is pick a kind. What that means is you're picking a card. Well,
13, choose 1.
13 choose 1 because there are 13 cards. You're picking one of them. Of those 13 cards, once you pick one of them, how many cards of that kind are there? 4 of them. How many of them do you want? 3. Now you have to pick another kind.
12, choose
12 choose 1. Very good. Because you've already picked one kind, you want of another kind, so there's going to be a 12 choose 1. Of that kind, how many do you want?
4, choose 2, sorry.
Are you cheating or something here? Genjo. Don't play cards with Genjo, he's going to have something up his sleeve.
He always does.
Well, I might, but it's not gonna be this.
The deck. That's shock. Totally.
Now the difference between doing this and then the next question that's on here about the probability of card being a spade or a 7 when you're just picking a card. That is when you're talking about probabilities. So if you're looking at a probability of a spade or 7, well, how many spades are in a deck of cards? 13 of them. So there's 13 out of 52 are spades. How many 7s are there? 4 of them. But how many of those 4 are a spade?
Oh, that's why I got that one wrong.
Sucks to be you, Clyde.
So your answer would be 13 out of 52, 8 out of 26, 4 out of 13.
Nuts.
That's how that one looks.
Those were you can use. Well, I also kind of forgot the permutation and where you.
Permutation versus combination. Combination, notice what we're looking at here. We're using combination because we're just counting possible occurrences. The order doesn't matter. You're saying how many ways can you get spades? Well, there's all these different ways. It could be first, second, third card, or whatever. But when we talk about permutation, permutation is when your order is going to matter. It's the idea of having 10 people in a room, or 10 people in a club, and you want to fill the office as president, vice president, and secretary. So you have 3 jobs that you have to, how many ways can you arrange the 10 people into 3 jobs? Well, the president is going to have his job, not somebody else's. So the order matters.
4 jobs.
How many ways can you, or whatever it was, however many ways people can win a race. You have 6 people in a race, how many ways can they come in first, second, and third? Assuming there's no ties. That's your permutation, because the order matters, unless it's Thomas, where he wins and he comes around and takes second because he's faster than everybody else.
Wait a second. Can you redo that president one? That president? No, actually, I just want to know how I got that one wrong.
Yeah. There's a mighty word in something like there. It says this.
What does that even, is that like the 10 choose?
That's what I thought.
As it asks you for the coefficient, it's asking for the number in front of the variable. I was over syllabling there.
Yeah. I thought.
So if I want to get the x, the coefficient of the 5th degree or 6th degree term in x plus 3 to the 10th, well, I have to use binomial expansion here, so it's a 10 choose, well, this is going to be x to the 6th, because I want the x to the 6th. my secondary term is going to be 3 to, well, to the 4th power, so that's got to be a 4 here. Remember, these two exponents have to add up to equal the highest degree. Okay? When you do that, you're just looking for the coefficient. When you do all that out, you wind up with 17,010 is your coefficient.
Wait, how's the word coefficient?
I did it.
Yeah, I did that. And
Okay.
I got that wrong.
But you wrote down next to that, what's the coefficient?
What if I circled that number after circling the
Those are the coefficient referred to,
Also, I managed to switch my goal.
That's not fair.
Jen?
Okay, I was thinking for that day, but so is that number, the 17, 0, 10, is that equal to 10 choose 4?
10 choose 4 times 3 to the 4th.
I didn't
Okay.
take it times 3 to the 4.
oh.
Yeah, I thought it was.
The other one is on the second problem there where you had the, what is the term? That's when you put all of it together.
Yeah, I did it.
The term on that one, you had a, let's see, it was 2x minus 1 to the 9th, and you wanted the 5th term. Well, that means if it's the 5th term, when you go through it, you winds up being, oh, watch what I do here. Parentheses, 2x, oh, to the 5th. Oh, boy, what do you do to the 2? But it's the 5th term I'm talking about.
32 it.
You're 32 it.
What do you 32?
What's 2 to the 5th? Oh, here comes another quick question for you. What's negative 1 to the 4th power?
One.
And then whatever 9 choose 4, you got to multiply it out there. Ladies and gentlemen, parentheses. So you wind up with 4032x to the 5th. It's positive, guys.
Wait, what did you end up with?
Is that the entire
43.
thing? There's no other number?
43?
Have a good one, sir.
I will.
Stay out of trouble.
I'll try to. So the final answer is 4032x to the 5th.
4032x to the 5th. How's that?
And then I added mine. God dang it.
It goes, it starts at 0, right? So that makes the 5th term the 4th. That's like 9 choose 4.
No, it starts at, when you're doing exponents like this, when you're talking about binomials, you start at, hey! What's up, Mr. G? Come on in. How are you? Good. We're talking about binomial expansion.
I just figured I'd check out what you guys were.
We're doing this in probabilities.
This is awesome.
Binomial cumulative distribution.
I'm gonna
functions.
leave. This is a lot.
Wait, hold on.
Play in the war.
There's more.
You might hit the war.
7 spades.
What is it?
It's 7 of spades.
Don't listen to
Don't
that.
listen to him.
I
Don't listen
can't
to
see
that.
it.
I
So.
bet it is a 7 of 3 of spades.
I don't know.
Is this a trick?
What is it?
3 of spades.
The ace of spades.
It's
What
was it?
Close.
6.
Oh,
I'm working on it. You know,
Get there.
because I wasn't thinking that.
All right, now I'm ready.
It just occurred to me it's 5 either way.
Is it a 6 of spades?
That's what 6-year-olds do.
Okay, I'm done.
Ace of spades.
Oh, it just occurred to me with the 6 of spades, he was 5 off either way because there'd be 1 or 11 of the ace of spades.
It was almost as big as my realization that 60 is less than 42.
He was 1 or 11, he was 5 off.
Finish right.
It was almost.
Now look at
When you get into the rest of this stuff, then a lot of this works out to be
No, I got it.
simple probabilities. Tossing a coin, rolling a pair of die, things like that. Not overly complex. Compound events. When you're talking about compound events, you're talking about your ands and ors. That was when you're looking at the idea where we had the question where it was, what was the probability of flipping a card over and it was a 5 or a 6? That's a different one. It's a different question. If I'm looking at 5 or a 6, you're adding them together because you have 4 5s and 4 6s, therefore there's 8 possible cards out of the 52. Now, if it's a 5 and a 6, can that occur? That's 0 because it's not gonna happen.
It sounds like
Emphasis
hopping.
the syllable again. Now, the other thing is, what happens if it's 5 and a heart?
Also multiplication.
And it is one.
It's one out of 50.
One. Yeah, so it's very subtle in how that works out. Okay?
Trick you.
Yes, ma'am.
Is it 1 or is it 1 over 52?
1 over 52, yes, I'm talking probability, sorry, we were just saying, they were just saying 1, and yeah, that's gonna be 1 out of 52. Okay. The other part where when you start looking at your compounding events, if they're independent events each time. If I'm rolling a die and I want to get a 2, pick it up, roll a die, I want to get a 3, pick it up, roll a die, I want to get a 4. Are each one of those events independent of each other?
Yes.
So what's the probability of getting a 2?
1 out of 6.
What's the probability then of getting a 3?
1 out of 6.
What's the probability of then getting a 4? What do I do with those probabilities?
Multiply. Multiply.
There you go. Okay. Difference there. Whereas if I wanted to get, oh, what was the compound number I had earlier? What do you got?
Okay, so take replacement without replacement with cards.
Okay, replacement without cards. That, you're right, that's a dependent one. If I want to talk about replacement without replacement, if I'm going to pick a card, if I'm going to pick 3 cards, and I'm going to go Jack, King, Queen. And I'm going to pick 3 cards. I'm going to go Jack, King, Queen. With replace, or let's do it without replacements. We haven't done that yet. What's the probability of getting a Jack out of a deck of cards?
4 out of 52.
4 out of 52. Now this is without replacement. I just picked 1 card. What's the probability of getting a king?
4 out of 51.
Now what's the probability of getting the queen?
4 out of 50.
And here, there's still independent flip overs, but just without replacement. Okay. What's different then if you had to go lucky sevens?
Why is the 6s?
Because that's the devil. And we're turning the page.
Thank you.
You're welcome. If I wanted to go 7, 7, 7,
It would be 4 out of 52, then 3 out of 51, then 2 out of 50.
good.
Oh, yeah.
Because I'm going with, if I'm doing without replacement, that's, it's dependent upon the fact that I've already gotten a 7, I got another 7. Oh, lucky number 7, I need a new deck of cards. I don't know.
So will you ask us, like, it's probably 5 7s, which is 0?
I need a new garage door opener.
Yes. Hey, speaking of which,
I got the garage door opener yesterday.
I need
do you guys know that your zip code is important?
Yes.
Did you know that your zip code is not the code on your garage door?
Yes.
Yeah.
Okay, just making sure.
Why? What?
We had this discussion that some people thought zip code meant garage door code.
No.
You gotta be kidding me.
Those are
You put that on.
very
I
unintelligent.
thought, yeah, it's my garage code.
It's like my garage code is 4, did you wonder my garage door opens?
Who said
Now,
that?
I just wanted the class earlier today. I don't know, but wait, let's just say that that person said that their garage door opener had 4 digits. Okay, all right, so there's 4 digits in your garage door opener. So it's 0 through 10. And if you have 4 digits and they can repeat themselves each time, that means you had basically, was it, not 0 through 10, 0 through 9, so it was 10,
10 times 10 times.
Wait, I said 0 through 9. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay.
Right.
Which makes
10 to the
10.
4.
So you had 10 choices for the first value. You had 10 choices for the next one, 10 for the next one. So that gave us some value, some possible range of things. Well, she said, oh, I said she. It wasn't Cullen. It wasn't Cullen. But she said, oh, our numbers are near and dear to my heart. So we equated that to birth dates. It took us about 10 minutes to hack her garage door code. Just from a couple simple
It was Izzy,
tricks.
wasn't it?
It was not Izzy.
Whoa, that's surprising.
It was not Hannah.
What's the rules? Wait, no.
Watch the video. Guys, watch the video.
Oh, so we don't have her.
Just like go in. This is stuff in our garage.
But it's just probability.
Let's throw a birthday party.
You guys can't figure out.
Do you not have one?
I just got one. I don't
Yeah, we did too.
My garage door broke.
I don't even have
We
a
got
garage.
it in garage.
My garage.
We're back down there.
But you're gonna be a garage door salesman.
Yeah, so maybe I'll get a garage someday.
Well, lucky you,
Your
Jessica.
garage door broke. If you were selling them by now, you could have sold a garage door.
I could have made so much money. I could have made enough money to buy my own garage door.
The rest of the stuff that's in here,
I'm dropping out of school.
Oh, no, it's 44.
we use the ideas of the, where was it? The counting principle stuff helped us get the binomial distribution of, multiple guess on a multiple choice type test. When you had the probability of, guessing it correctly 15 out of 30 times, we would do the binomial stuff for that. Just watch your directionality, which direction the greater than or equal to or less than or equal to things are working in. It should be okay. I'm really hoping that it's not scary. It covers a lot of material, but I don't think it's more than, I think it's like 10, 11 questions. It's not that much. Shouldn't be. I never read
The quiz was 12 questions.
It was 13.
13 plus 86.
Yes, ma'am.
Are you gonna give us the long equation with like the NCP and up to the K?
It's a binomial one.
Yeah, the big binomial one.
Where you have to actually multiply it out. Don't you have a button for that?
Oh, so we're not doing that anymore?
Oh, no, you can still, are you talking about doing the whole binomial expansion of writing out the full thing?
Yeah.
Is that what you're talking about? Like, you're talking about doing this?
Yeah, the one we learned in 12.6, yeah.
This, 12.6. Oh, yeah. In 12.6, what we did in there with this is it's simple, though. What you're looking for is if you have the probability, and I'll do that example, I just put that up. The probability of, which button was it?
You can do this with any of those probability area problems?
Might, you never know. In this one here, these are what you're talking about. Where you have the probability of, you have 30, your n value is 30. And you wanted to get, what's the probability you're going to get 25 correct if you just randomly guess? Well, if you have 4 choices to randomly guess, what's your probability of success?
0.25.
So your p-value is 0.25. What's your 1 minus p then? And if you want 25 successes, that means all that formula did was 30, choose 25, 0.25, and you wanted to get 25 right. And then the other one is 0.75. Well, what do you have to add to 25 to make it 30? 5. Okay?
Make it harder, make it the card back. Just pick a
I
card.
can't.
I forgot where you forgot the one minus P and
Yeah.
you forgot to remember to do like a K equals something and then like a.
That's this one right here. That's that one right there. It's that straightforward.
Oh.
Remember, I don't like using the worded out stuff. I like to do my best to make it a little bit more simplistic. And that's a very simplistic way. Just, you know that you have 30 of them. You want to get this many right. This exponent and this one are always the same. This is the probability. This is 1 minus it. And these two have to add up to equal that. I don't try to go through all the different K and because it just gets to be messy. And if I'm not mistaken, one second, hold on, you had a question here. If I'm not mistaken, this is the binomial expansion part where you want one expected value, isn't it? Isn't that binomial PDF? That's a binomial PDF if you put in, what do we have? 30, comma, 0.25, comma, how many did I want to get right? 25, right? I think that's right.
Did you say 30, 25? Or
Yeah. So let's see if this is the same. I think it is.
was it 30, 0.25?
Yeah. might have flipped it around, maybe it's 25 point, whatever. That one.
Well, the code says this problem is the opposite, the R value or the K value matches the right side. Like, we were talking about the problem.
Yeah, I think
with,
so.
like, The fifth term, it's like 924, and the number has the fourth out.
Yeah, that's right. Sorry, Cole, I didn't forget you.
How would you do number 7 on the quiz?
It's the secretary one.
Yeah.
4 positions, 10 people.
10
I did
people.
agree.
Is that what it would be?
Call it.
I did 10.
10 people?
Yeah, because that's,
Ah, nuts.
is the president gonna be the treasurer?
No.
Oh, I did 10 C4.
That's what I did.
You blew it up. Yeah, C4.
Yeah, I get it.
You killed 10.
What'd you do, Lincoln? 10?
No, you got 10.
I actually did 10
Yeah,
C5
that's
for
like
some reason, which isn't the right answer, but that's okay.
Anything, oh, anything else? Shouldn't be bad.